12 looks like, maybe. What's 12 look like? Which one? I didn't do all of them. If you want me to do, if you can do these, you're probably okay. That's my check. Now, if you're like, no, really, I need to see 42. We'll do 42. No, totally. I'm not. It's now. If you're just copying down answers, I'm going to skip 42. You have to do that later.
I'm not copying down answers. I was just checking my answers.
Okay. Are you happy with all these?
Yeah.
And there's no such thing, right? Like a big circle around 42. Going, I need help with this.
No.
Okay. Okay, not later. You're gonna ask me now because somebody else has got the same exact question. That's the way this works. 12. I got my 12. And 12 looks like this because it is a parabola. X squared plus 2 everywhere except at x not equal to 1. And then it's, what is it at that spot? It's 1 at x equals 1, correct? So if it's that, we know it's a parabola, we know it goes through 2. How do I know that family of functions? Agree? Shift up 2. But at 1, it suddenly does this, because at 1, we don't use that function at all. Is that okay? All right, so then I got to figure out what x equals 1, that's down here. So what am I approaching? Well, again, the question isn't what do I have, it's what I'm approaching. So as I come from the left and right, I'm coming to this spot right here. That spot looks like the function is equal to 3, I believe. So I would say the limit of this function as I approach 1 is 3. But it's what? No, it's not. That's what it is. It's approaching 3 from the left and right. It never reaches 3, but it approaches 3. Is that okay with everybody in the room? And we're doing okay. We're doing okay. What's the other one? Go ahead. Go ahead. What are you wrong? Okay, hold on. You asked a question that's horrifying me. Can I take a moment? I need to talk to this lad right here. What? No. It's not approaching 1. Now, here I am. Now, here's the problem. This thing is going to start triggering and making strange things. So you just have to be with me. As my fingers, maybe I can do it this way. It's going to work great. Okay, as I approach from the left and right, that spot, what value of the function am I approaching? 3. I'm not approaching 1. It is 1 at the spot, but I'm not approaching 1 ever. Okay? There's actually no way to approach 1 because there's a dot in space. Is that okay? Yeah. Okay, sorry. I heard that. I said, maybe we had a question about this, and you said 1. I'm like, that was the question I was hoping somebody asked, or hoping nobody asked, and they say, got it. So you said you wanted a specific question about 44? 44?
Well, I guess I'm just. Is that when you factor then?
You could, or you could look at the pretty graph. Okay, look at the pretty graph. What it says is when x approaches 1, that's where this asymptote is, correct? Mm-hmm. Which means it's plunging here and going up here. Are they approaching the same thing from the left or right? No. So then for 44a, I would write the following. The limit does not exist. Okay? Then the second question is, what's the limit as x approaches 0? As x approaches 0, it's over here. Now that's a hole there, but it doesn't matter. It's right. It's what I'm approaching, correct? Well, it doesn't matter. It's approaching. As I get close to this spot right here, what am I approaching? Right? Even if I approach it over here, at some point I'm getting closer. Does that make sense? Okay. Now, be aware of this. AP Central loves this question lately, and it's kind of annoying. They like to do this. You ready? Limit as x approaches 2 of the following function. 1, 2, and this is like a 1 over here with me. As x approaches 2, what's the answer?
0. X approaches 2.
That's x approaches 2. Like 1-ish, half-ish, right? Okay?
Is that like where the curve is?
Well, it's wherever the curve would be right here. Wherever that spot is right there. Okay. What are they actually messing with? When you see this graph, what do you think the limit is? The limit does not exist. You think it's saying approaching zero, but they don't anymore. They kind of like caught on to the fact that people were just kind of, oh, it's got an asymptote. It's clearly got a limit does not exist. That's not true. It's wherever the point is that you're actually approaching. Does that make sense? Now you're right.
Because the arrow pointing in at 7 is the same.
Well, we're approaching 2 here. So, what do you mean over here?
No, I'm talking about that one.
This one here. The limit is x approaches 2. Because 2 is over here. So I'm approaching left and right. I'm approaching whatever this value is. I'm going to stick at 1, but maybe it's too low. So I have to whatever it is. Does that make sense?
Yeah.
Now, when it's s, that's the limit as x approaches 0 for this function. This is going this way. This is going this way. We're not going to the same place. So the limit does not exist.
So they're approaching the same x value, just not the same y.
Right, they're always approaching the same x value.
Okay, let me write that.
Yeah. So y value, that's the limit. That'd be the problem. Guess what you get if you plug in the equation? You get 1. You couldn't plug it in, could you? Anytime you see a piecewise function, don't plug it in. Look at the picture. Because there could be a break there, and the limit does not exist. Or it could be a hole there, in which case the limit exists, but it's not the value you get when you plug in the number. Right? Because technically we should plug in 1 to do the function, right? If I plug in 1, I would go over here and go, well, it's not 1, no, it's not 1, so it's 1, so it's 1, 1's my answer, and that's not correct, right? What you care about is what you're approaching. All right, this one often appears in the AP test. They like that problem too. I don't know why. It doesn't really, it's not really kind of a weird problem. Like, okay, they're trying to fool you by not knowing what a piecewise function is, or they're trying to fool you with something that doesn't quite the limit idea. Yeah. False one of these. All right.
And we looked at 17.
17, not yet, because we just told you to stop at 12, so if you're listening to instructions, that wouldn't occur to you to do 17 yet. All right, with that in mind, let's flip into the front. Let's talk. So one of the things we're going to talk about limits. Wait, what are we waiting for? Okay.
I just had to decide what you said.
So confused. Okay. You're going to see this one. All right, everybody try the problem at the top. Go, go, go. You should be able to do it.
What?
The problem on the top, please do it. Yes.
Wait. Let's go.
Should be quick for everybody. What are you doing? On the top, let's go. Get behind them. We're in daylight. He's in the parking lot. He's not even here yet. Mark Damaris is still going to turn it.
Yeah.
I did. I told you. You know that. Rude. You're going to very much.
Oh, you talked to Zarko.
Okay, so there was.
No, you like three.
Oh, sorry.
You are like, I like really, you like come scared. You're talking to something I don't know.
Oh my gosh.
Why are you alive?
All right. Everybody take a look at that. You should be able to do this problem by now, hopefully. With malice of forethought, you got limit. Oops, somebody's going to help me with this in just a moment. Limit as x approaches 1. Miss Dumbridge. This one's yours. How do we do this problem?
You factor it out.
Okay, before I factor it out, I'm going to check to see if it's 0 for 0. It is. So I'm going to assume you did that. Just didn't tell me that. You skipped that and figured it out. Right. Okay, factor. He's going to say nothing while I do the whole problem for you.
And then you can.
That's not the way I work, because I don't know how to do math. Gotta help me out.
Yeah, and then you cancel out x minus 1.
Oh, okay.
And then you plug
I
in
should
0.
know how to do math?
Yes.
Who says?
Why would you need math?
Why is it equal 2? Oh wait, I was, never mind. Yeah.
Okay. Okay, so then you got your graphing calculator, which I told you to bring at the end of this class. Now a good time to show off your skills. I want you to graph this function. Graph it. Because your calculator is too stupid, it doesn't hold it. I graphed the top function, x squared minus 1 all over x minus 1. No, I said go back to the front. Next page. That's your problem with me. At that moment. Yeah, starting. Wow. You guys good back there? Catching up? Wait, that's what? You're supposed to make it.
Then you have to emphasize it.
Well, that's because I'm not heavy graphic calculator. I apologize.
Oh, no, a charger.
Charger? Maybe a little more. Crazy too. I don't have those. You just charge the calculator. But she's a sucker bought a TI with a recharge. Nothing worse than buying a TI. All right. But you're saving the earth by buying a credit calculator and replace it a couple years later. Moving forward. This is what it looks like. So, as x approaches 1, what are we approaching? 2. That's correct. Not a problem at all. So sometimes the easiest way to do this is that if you have your calculator available to you, is get your calculator, put the function in there, and look at the pretty picture. Especially if you can't figure out what the function's supposed to look like, or you can't do the math, or you can't factor it, you just, let me see what it looks like. Oh, it looks like that. That's great. Now, somebody over here had an objection to the graph of your calculator, didn't you? Which is what?
It doesn't have the hole.
It's missing the hole. There is a hole there, right? We do know at x equals 1, it does something awful.
Yeah.
So there's a hole there. Okay, we canceled out the x minus 1 piece. So there actually would be, if your calculator is smart enough to do it, a hole here. So in theory, the graph actually looks like this. But still, we can do it just by looking at the pretty picture. Now, first thing, you need a calculator to look at these things. Sometimes they don't jump. What was the other thing I was going to have? Something else really there, but I guess I lost it. Okay. All right, does that make sense? Check left and right. Are these good? One more. Oh, that's what I talked about. Listen to me carefully. One of those cute little AP Central hints. They know your calculator better than you do. A couple years back, they gave a function that looked like this. Y equals, and it was like 5 sine, and I forgot it was like 14734 t plus 3 plus whatever. And essentially, one of the questions asked graph it. And you graphed it on a TI back then. The TI would do this at 5. Now listen to me carefully. That's the function. Does that function give you a line? No. You're supposed to know that. So sometimes they will look at your they'll throw something on the test where you have your calculator in front of you, like, oh, I'll just graph it on my calculator. Things like that, they expect you to know. It goes like this. They expect you to know that. And they feel perfectly valid in throwing out a problem that makes your calculator say something different or look at something different. Okay? Now, if it's a really funky function, they're not going to do that to you. They're not going to do it for arctangent of sine squared. Okay, yeah, whatever. You don't know what that looks like. But with something like this, they do expect you to be able to go, wait a second, my calculator is lying to me. That's not good. And then get around it. You know what I mean? So don't believe your calculator every single time. We'll mention that again when we get to chapter 10 later this year. Oops,